Odd. Don't know why the thing just crapped out, but it did. Anyway, I was talking about how there was a bug in the schematic relating to. I'm trying to hook up a microscope camera while I'm talking. Relating to. Let's see if the microscope will work. Is it this one? Is it this one? It's that one. The analog to digital converter. Why is that so blown out and blurry? Let's see if we can adjust it. I don't think I've got to work on better optics for this microscope. Anyway, this pin here is a master slave select. It gets 3.3 volts to tie it high for master. Problem is, for some reason, the data sheet specifies they want a 10K current limiting resistor on this input pin. Then I feed that 3.3 volts over here to the oscillator. So I'm going to cut this trace here. This trace back here is that one there, I'm pretty sure. So that's where the 3.3 volts comes across to that via, which pops up here. So if I cut here, who's texting me? If I cut there, I should be able to stick in a resistor. So first thing I'm going to do before cutting the wrong trace is I'm just going to scrape back a little bit of the solder mask. Let's find ourselves a known good 3.3 volts. 3.3 volts is there, which is this one there. All right, so those should be, you don't have enough. You can't see enough. Voltmeter. I think this shiny package is blowing out the camera a bit. Great thing about doing this live is you can see how boring a lot of this stuff is. Continuity mode, 3.3 volts. Okay, that's 3.3 volts. So we want to stick a 10K resistor in there and jumper from that 3.3 volts there all the way over to here. Let's stick the 10K resistor in first because why not? I'm going to do that on the microscope because it's small. Where do you go? There you are. I don't know why it looks so blurry to you. I'm going to need to cut the trace here without cutting my finger too badly. All right, it's cut. I'll cut next to it as well. Make a nice big opening between the two. I'm going to zoom in. Sorry, it's so blown out on the camera. I'm really got to fix my microscope optics. Well, I can see that's not really a cut. Okay, definitely cut the trace there. All right, we'll expose some pad there, some pad there. Let's get our multimeter and make sure that we don't have a short. Now we've cut the traces. We've cut the traces. All right, let's get ourselves a small little resistor and stick it in there. I think the smallest thing that I have on hand is an 0603. I think the data sheet, I should look up the data sheet and see what it recommended, but it's a current limiting resistor. They said 10K, so I got a 10K 3.3, 603, 0603 right here. So give you all a sense of scale. So here's my pack of resistors. Let's get one out. It's where is it? Can you see it on the screen? There's that thing right there. Let's whack that in the circuit. All right. first thing we'll need to do is tin the pads, or turn the, let's switch to a smaller soldering iron tip, because that will be better. Smaller tip. All right, let's go to the back of the microscope and see if we can tin those pads up. See if we can find where they are. All right. What's going on today? We are assembling a digital to analog, or sorry, analog to digital, then digital to analog audio circuit, just to test out this I2S protocol for audio, which I'd never heard of before. But first, I'm bodging in a current limiting resistor because I didn't read the data sheet before I designed the PCB. Some flux might be useful. Let's do that. I just completely burn up that copper. No, I didn't. Come on. I think there's still some solder mask on. What have you done before? Bodging in resistors or I2S stuff? Oh, you can't see what I'm doing. Sorry. All right. We have some solder. Let's get ourselves some tweezers. I don't know why I keep on putting away my favorite tweezers, because I always just use them. I have this set of tweezers, and these are the guys I always seem to go for. All right, let's stick on that massive resistor somewhere around there. And I've way got those dimensions wrong. I need to expose some more copper. All right, let's do that. Let's move this resistor out of the way and make these pads larger. And it looks like carnage there with all the flux, but it's actually not too bad. It'll clean up nicely. It's way too big of a blob of solder. Get out of there. Go. All right. We should be able to get that resistor on now. Orientation there. All right. Sorry for the focus again. I don't know why this camera, even when it's in focus, it just looks really blown out. Yeah, this isn't I2C. This is I2S. I2S is a stereo PCM audio format that is used by a bunch of things in the audio world. Never heard of it before, but I'm helping a friend out with a project because it's fun to work with friends. So I'm making this board as just a way of familiarizing myself. Is that standard? That's one side on. Believe me, you can hardly see it. Let's get the other side on. CDMI connector. No, this is a designed for use on PCBs, so just a chip-to-chip communication. HDMI? No. So HDMI, I'm not sure what the audio format is on HDMI. Yeah, it's not designed for like transmission. It's just designed for going from one chip to another. Now I'll put a little bit more solder on this side. All right, that board should be good. All right. So now the board won't lay flat, but that's okay. The next thing I want to check, because I always get this wrong, is whenever I'm buying connectors, I always seem to get the wrong pin out or the wrong footprint. I had to I had to draw up a bunch of different footprints. Look at that. I totally got this wrong. How did I get that so wrong? That's okay. Oh God, I've done this before. This is my audio input. I can fix this later. It always seems to happen with this series of RCA connectors. In fact, no. I chose this series of RCA connector because they already had a footprint in KiCad. And this is the second time I've done that, where I've used the footprint and it's wrong. That's okay, because I can fix that. And the way I can fix that is if there's enough room. All right, so this pin here is shield, that pin is signal. This is the one that needs to be signal. It'll fit there. You can't see what I'm doing, but it'll fit on one side. This entire board is just covered in ground plane underneath, so I can just drill a hole in the board. It's butchery, I know, but I'll get it to fit. Anyway, that's not a problem. This is the last thing I'll connect is the audio connector, because I'll do other things first. Or do I want to start with doing drilling to the board? Yeah. It's amazing. Like, this was a project that I whipped up in one night, and how many things do I get wrong? I've got resistor on the back wrong, and the footprint for my RCA connector is wrong. How do I want to fix this? Yeah, I don't need to do anything else with the back of the board. I'm just thinking about order of assembly. If I had parts on the back, I'd want to keep the front of the board as flat as possible, so that when I'm flipping it over to solder the back, it would be easy. But there's nothing on the back except for that resistor I just bodged in. So I can put these in. And I think I can do it in an even nastier way that doesn't involve soldering the board. So if we bend this pin out, put that there like that, and wrap it around the edge of the board, I can put a lead on the back. Lead on the back to make it work. That'll work there, and it'll work here as well. All right, sweet. Okay, not too bad. Let's do that. Let's be horrible and nasty in the way we stick these on there. Let me just double check that I'm getting the right pin, that this is the center pin. Yeah, it is. All right, good. I'm going to need to switch back to a fat tip on my iron, because the heat output difference is pretty big from my micro tip to my less micro tip. So let's stick this in there. Try and keep it flat while I'm soldering it. I'll I'll get my fatter solder, not that it makes a difference, but let's do this. Flux. Get a big gob of solder on there. Just tack it in place for now. And there's not enough solder. I'm gonna get myself one of these guys and just stick them all in the board. That way it'll be balanced. There we go. Don't need 3 hands now. So you want to hit the pin, not the solder, to get it to join properly. Let's do this one over here. A little bit of solder melting at the start helps conduct heat to the center pin. There we go. That's straight enough. All right, let's stick the other ones on. Unless they both fit on here, that would. Hello. Did I leave myself enough room to actually plug in RCA cables? That's another question. All the little things you don't think about when you're using different connectors. All right, I've got 2 RCA cables. Will they both fit plugged in? I'm saying that's a no. Of course, I did 1 left channel and 1 right channel. I could have just stuck it as 1 channel. Let's do that. Let's just do 1 channel. Take this guy up. Stick it in here. All right. Project has gone from stereo to mono until I sort out this connector situation. Oh, moved too soon and made my life a lot more difficult by filling up that hole. I think I can probably just shove it in. All right. Okay, we have our 2 audio inputs. Now we can go back to a fine tip. And I think the next thing we'll do is power. Put these guys back in the bag. So there's no power supply on this board. It just takes 3.3 volts in, which I can supply externally. I generally don't like doing power supplies on new projects because I really like having all the individual rails, and this only has 1 rail, like 3.3 volts, but all the individual rails available for me to be able to meter them. Particularly for a new board spin up, you want to see the current draw. So a little female pin header thing. We'll whack that one in there. And this would have been better to do beforehand because I'm about to burn my finger just a little bit. I probably should have stuck with the larger tip for this one. It's only not wetting the tip. I'm going to switch back. Ow! Said I was going to burn my finger, and I did. These conduct heat very well. I don't need a good solder joint. I just need enough to hold it in while I free up my other hand to get the other one on. Then go back and do the joint properly. One sec, I've got to go.